Hello everyone. Today we are going to talk about glaciers, deserts, and wind-driven landforms, and most importantly, how these processes shape landscapes that you see around you every single day. So what are glaciers? Glaciers are thick masses of ice that form over hundreds to thousands of years. In places like Antarctica, ice cores contain ice that is hundreds of thousands of years old, giving scientists a record of the past. Glaciers are controlled by a balance between accumulation and wastage. When snow accumulation exceeds melting at the end of the glacier advances. When melting exceeds accumulation, the glacier retreats. Snow accumulates at the top of the mountain and pushes down towards the glacier, and that just happens through regular snowfall and precipitation at the top of the glacier. Glaciers retreat or melt through normal climate patterns. So in the summer times it's warmer, and in the winter times it's colder, and so glaciers will retreat each summer, and that's normal retreat. As glaciers advance and retreat, they grind, scrape, and roll soil and bedrock beneath them, reshaping the landscape. How glaciers move and erode landscapes. Glaciers behave exactly like they sound. Ice that accumulates at the top and sides of mountains then flows downhill through valleys. And we call those alpine or valley glaciers. And those are the types of glaciers we find in Glacier National Park in northwestern Montana. They flow through the mountain valleys and erode the surrounding bedrock. This erosion creates distinctive features such as cirques, arêtes, horns, and fjords. The classic example is the Matterhorn of the Swiss Alps. Its pyramid-like shape at the top is not accidental. It's the result of glacial erosion. Once the glacier that carved it is gone, the landform still remains, and we have a record of the history of that landscape. Ice sheets, on the other hand, are much larger than alpine or valley glaciers. They cover entire islands or continents, with ice flowing outward in all directions. Antarctica is an example of a continent-scale ice sheet, while Greenland is an example of an island covered by an ice sheet. During the last ice age, about 18,000 years ago, ice sheets covered most of North America, including Minnesota, and created many of the landforms that we see today. Because glaciers once covered so much of the United States, glacial deposits are widespread. In southwestern Minnesota, one of the easiest glacial features to recognize is end moraines. Every time the glacier paused during its retreat, it left behind piles of till, which are a mixture of clay, sand, gravel, and boulders. These moraines formed small ridges that trend northwest to southeast near places like Marshall, Minnesota. One particularly important moraine marks the watershed divide between the Minnesota River to the north and the Des Moines River to the south. And you can see this really clearly at Kylan Woods State Park near Lakeville, Minnesota. That pile of glacial sediment was large enough to permanently change where water flows, shaping the regional drainage patterns. The Ice Age. When we talk about the Ice Age, we're not talking about Scrat trying to hide acorns and causing major geologic events throughout history. The most recent major ice age began about 2.5 million years ago and is known as the Quaternary glaciation. Fun fact, we're still technically in that glaciation. While ice ages last millions of years, the glaciers continue to advance and retreat during warming and cooling trends in shorter cycles. So the last major glaciers in North America began retreating around, between 20 and 10,000 years ago. At their maximum extent, the ice sheets reached as far south as Texas, skirting around the Rocky Mountains, which primarily still hosted alpine glaciers. Now we are going to completely shift gears into deserts. Desert is defined by low precipitation, not necessarily related to the temperature. Technically, Antarctica, which receives very little snowfall, is considered a desert. The major deserts around the world include the deserts of southwestern United States, the Sahara in Africa, the Arabian Desert on the Arabian Peninsula, much of Australia, Patagonia in South America, the Kalahari Desert in South Africa, and the high elevation deserts in the Tibetan Plateau. Most major deserts are located around 30 degrees north or 30 degrees south latitude due to global circulation patterns, and we will talk more about the Coriolis effect in a later lecture. Some deserts are not created by latitude, but by topography, namely mountains. When moist air blows toward a mountain, the air rises and cools on the windward side, producing rain and lush vegetation. This happens because the clouds and the precipitation get hung up on the height of the mountains. The wind is still blowing, and as the air descends on the leeward side, it becomes drier, and it shoots down the side of the mountain, creating what we call a rain shadow desert, and these are also called semi-arid steppes. One example of this rain shadow effect is seen between the city of Eugene, Oregon, which is green and lush and forested, and Gillette, Wyoming, which is dry and semi-arid. Even though those locations are at very similar latitudes, they have very different climates due to the mountains. Moving on to wind erosion. So wind moves sediment much like water does, but with a few key differences. So wind is less dense than water, so it can pick up smaller materials or less dense materials. So the particles that wind tends to suspend are silt and clay, while water can suspend things like sand and even small pieces of gravel. The other big difference between wind and water erosion is that water is limited to the river valley that it is traveling through when it is eroding something and transporting it to a new location. Wind, on the other hand, can carry sediments and particles all over the earth. So it transports material much farther, both vertically and horizontally. That's why volcanic ash from Mount St. Helens ended up in Minnesota. So after the wind has deposited silt, clay, or sand usually after dust storms or sustained wind or sustained wind regions like deserts. Fine silt is deposited as loess, and that's spelled Loess, but pronounced like Loess the name. In sandy environments, on the other hand, wind forms sand dunes, and they're incredibly useful for determining the wind direction at the time that the sand dune was created, which means we can get a glimpse into the wind patterns of past regions. The crescent shape of the dune shows the windward side where the sand is accumulating. So in the drawing you can see that it has a crescent shape and one side is kind of bulging. That's the windward side where the sand is accumulating. The leeward side looks like it got a bite taken out of it. These structures are very similar to snowdrifts, and so if you live in southwest Minnesota and you're dealing with any of the recent blizzards that we have, we understand that really well, especially when strong winds are coming across the region from areas like the Buffalo Ridge, where there's higher elevation, the wind drops down, picks up speed, and picks up those particles also. So why does all of this matter to you? The biggest takeaway from this particular lecture is learning how to recognize landforms wherever you live. So as you're driving along the highway and you're looking out the window, do you see hills? Where did they come from? Did they come from glacial deposits, or were they volcanoes, or were they mountains at one time? How did they form? And this kind of information is just kind of interesting to know. Do you see any evidence of ancient deserts like sand dunes? Can you see crossbedding, so piles of sand dunes that stack up and show the wind changing back and forth as a record of a desert? These types of landforms are records of past climates, wind patterns, and geologic processes. So once you start to recognize them, the landscape starts to tell a story and you can start reading it. And it's actually a really good book to read. Thank you so much for joining me. Have a great rest of your day.